In this section, we're going to cover multiplying polynomial by polynomial. In our last video, we focused on multiplying a monomial by a polynomial. So we have one term on the outside and many terms on the inside. So when we distributed, our example will look like this. We multiply coefficient by coefficient and use our exponent rules to combine the variables. Now I could leave this like this, but I noticed that this is not in the correct order. All of these terms have x's, but I want to write the x's highest exponent first to lowest. This is my final answer. It's not very important to do this right now at this stage, but it will come up later on, so it's a good idea to get in the habit of checking the order of your polynomial before you're done. In example 2, we have a binomial times a binomial. Now, when I go to distribute, I have to pay attention to the first polynomial. However many terms are in the first polynomial is how many times I need to distribute. In this case, I have a binomial in the front, 2 terms. That means I need to take that first term and distribute. I also need to take the second term and distribute. So because I have a binomial in the front, that means I have to distribute 2 times because there are 2 terms. So this is what my equation would look like. Taking the 2x and multiplying it by 3x squared minus 6 will give me 6x cubed minus 12x. Then I do the same with the 4. I then check to see if I can collect any like terms. This has an x cubed, nothing else does. This has an x, nothing else does. This has an x squared, and this is just a constant. So there are no like terms here, so there's really nowhere else I can simplify this to. However, I could write it in the correct order, putting the highest exponent first and the constant last. This is my final answer. So as we go to simplify, we first distribute, same as before. We then collect like terms, same as before. And now we're going to check the order of our polynomial. In example 3, we have a trinomial in the front multiplying a binomial. So trinomial in the front means I have to distribute 3 times. I take my first term and I distribute to the second bracket. I take my second term and distribute to the second bracket. I take my third term and distribute to the second bracket. So my next line would look like this. I then look for like terms. In the first one, I have a p squared. Nothing else has a p squared, so it stays. My next term has a pr, and in this one, I have an rp. Remember, the order in that we write the letters doesn't matter. It's like saying 2 times 3 or 3 times 2. They're both going to give you 6. So rp and pr are like terms. We're going to write them, of course, in alphabetical order. We then look for any r squareds, none there, no p's by themselves, and no r's by themselves. So when we're collecting like terms, these are the only 2 that I can put together. Sing the alphabet song and make sure that your alphabetical order is correct. Our p's need to go first, then our PRs, and then just the r's. So this is our final answer. Notice that this would also be the same if I wrote the 2 polynomials in the opposite order. If I had the binomial first, I would have to take the first one and multiply it 3 times, and then I would take the second one and multiply it 3 times. Try this on a piece of paper. See if you end up with the same terms as we did above. In example 4, we are given a binomial squared. A really common mistake that a lot of students do is to rewrite this like this. This is a really bad mistake. What we really want to do is pay attention to what does a square mean. When we were talking about exponents, we said 3 squared is the same as 3 times 3. So that means if something is in brackets and it's squared, that means whatever is inside the brackets is times itself. So we're not putting the exponent inside of the bracket. We are squaring the whole bracket. So don't do that. When we have a bracket that is squared, what we are saying is 3 minus y times 3 minus y. The whole bracket is squared, so times itself. This is a binomial times a binomial. I take my first term and I distribute. I take my second term and I distribute. Pay attention to the positive and negative signs. The next line should look like this. Once we distribute correctly, we then look for like terms. The 9 is a constant. It is by itself. We then look for any terms that have a y. I have 2 terms with a y. And then we have a y squared. That is the only term with the y squared. So I'm going to combine or collect these 2 like terms, and my final answer will be written in the correct order. Y squared, the highest exponent, minus 6y plus 9. Remember, constants go at the end. That is my final answer. In my last example, I have multiple polynomials multiplying each other. And this is very similar to what we did when we were reviewing BEDMAS. Anytime we have something like 3 times 6 times 2, we have multiple things going on. We read our equation from left to right. We do one thing at a time. We simplify. We bring the next step down, and we simplify again. And this is what we're going to do here. We're going to just focus on the first 2. This is a binomial times a binomial. So I take my first term and distribute. I take my second term and distribute. When I'm done simplifying, I look at the last term. So this is what my second line looks like. I collect like terms as best I can. So I put the 2 y terms together. You'll also notice that I wrote this in the correct order, but this is not where I finish. This is one of my first steps. I've simplified the first 2 brackets, but there's still a third one. So I'm going to put this in brackets. I'm now going to bring down the next bracket. Now I have a trinomial times a binomial. So I take my first term and I distribute. I then take my second term and I distribute. And I take my last term and distribute again. I then look for like terms to simplify as much as possible, and I write my final answer. Double checking that the exponents go from high to low, and I am good to go here. Thank you for watching. Don't forget to subscribe and click on the next video.